Happy Tuesday. Today we are going to get into the next unit. So we are on module or unit 3. In unit 3 or module 3, we are going to continue to talk about linear equations and functions, but we will also start to talk about exponential functions. And the main goal of this unit is to compare the two and be able to differentiate what is a linear function and what is an exponential function. In the graph, you can see, like we've talked about before, linear graphs are straight lines, and exponential functions have curves. So we'll talk more about each of those throughout this unit, but that is what we will be studying for the next couple weeks. So if we look at today, we're on topic A, which is linear and exponential sequences. A sequence is a pattern. We'll talk more about that. And today we're going to talk about you examining sequences, and you're going to be introduced to the notion used to describe them. Notation used to describe them. So again, how we create an equation or an expression that describes a sequence or a pattern. So if we think about that, take some time and think about why today's objective might be important. Why is it important to understand patterns and see the patterns in sequences and series and be able to describe those patterns? And are patterns relevant in any other subjects or classes? If you think about patterns throughout history, if you think about patterns in numbers, if you think about patterns in dates or times, if you think about patterns in nature, are there any other subjects or classes where this might be important? And when do you think you're going to use this again? When outside of this class this year do you think you'll have to recognize patterns? Do you think it'll be important to use what you've learned in this class? Is there any other time you think you might use this? And again, the answer might be no. There might some of this stuff in particular, I think is important and you will use again, but some things that we learn in here, you may never use again. If you ask your parents, do they use algebra every day? They might say no, but they might use it and not realize it. So getting started, the opening exercise, Mrs. Rosenblatt gave her students what she thought was a very simple task. She gave them a sequence, and again, a sequence is just a series of numbers or a list of numbers that have some type of pattern. So she said, what is the next number in the sequence? 2, 4, 6, 8. She had 3 students that all gave different answers. Cody said, I'm thinking of a +2 pattern. So after 2, 4, 6, 8, it would go 10, 12, 14, 16, and so on. Allie said, I'm thinking of a repeating pattern. So it's going to go 2, 4, 6, 8, and then repeat 2, 4, 6, 8, 2, 4, 6, 8, and so on. Suri said, I am thinking of the units digit and the multiples of 2. So it continues 2, 4, 6, 8, 0, 2, 4, 6, 8, and so on. So the question is, are each of these valid responses? Did each person create a pattern that makes sense given the sequence that Mrs. Rosenblatt gave? So if they're all correct, you can just say they are all patterns that make sense with the sequence they were given. If any of those are incorrect or don't make sense, go ahead and identify who was incorrect and why. All right, if we think about it, what is the 100th number in each of these sequences? So this might take some time. 2, 4, 6, 8, so that's the 4th number would be 8, 5th number would be 10. Think about how you could figure out the 100th number. I don't think you should have to write them all out. So think about how you can get to the 100th number for Cody's sequence if it's just adding 2. Same thing with Allie and Suri. Is there a way that we could figure out the 100th number without writing out all 100 numbers? That would take forever. And same thing with Surrey. Do you think there's an easy way that we could figure out how to get to the 100th number? And if we did that, we created a pattern, we identified it, we can think about an expression that can give us, in terms of n, for the nth number of the sequence in in Cody's scenario. So what expression could represent Cody's situation? So again, if we're thinking of this in terms of n, if we create an expression and we plug 1 into the expression, we should be able to get 2 out. If we plug 2 into the expression, it'll give us the second term in the sequence, which is 4, so we should get 4 out. If we plug 3 into the expression, we should get 6 out. And if we plug 4 in, we should get 8 out, and so on. So think about an expression that we could write that represents this sequence. Again, Cody, we're talking about Cody's pattern. He's saying it's a +2 pattern. So think about what we could write, what expression we could write that will get us those answers. And again, n is the number of the term in the sequence. So again, if we plug 5 in for n, we should get 10 out. So the pattern is +2, so why can't we just write n plus 2? That would make sense, right? It's a +2 pattern. If we have n plus 2, it should just give us it, right? Because +2 is clearly what the pattern is. Actually, no, right? If we think about it, if n is the term, if we plug 1 in for the first term, we should get 2 out. But 1 plus 2 is 3, right? So clearly that doesn't work. Same thing for the second term. If we plug 2 in, 2 plus 2 is 4, so maybe it worked for the second one. If we do the third one, 3 plus 2 is 5, so it doesn't work there. So this is why it doesn't work. Again, n stands for the term in the sequence, which of those it is. So the first term again is 2. When n is 5, the sequence should be 10, not 7. It would give us 7. So that's why it doesn't work. So we have to figure out, again, we had to figure out something else. And if we did that, we should have gotten 2 times n. So if we plug 1 in, 2 times 1 is 2. If we plug 2 in, 2 times 2 is 4. If we plug 3 in for n, 2 times 3 is 6. So that is what we should have gotten. We should have gotten 2 times n, or 2n for that one. And just to check it, the 100th term again for Cody would be 200. For Allie would be 8. For Surrey would be 0. So if you didn't get those, that was an easy way to check those last 3 questions. So moving on. Again, in that black one, if you click there, you can type your answers right in. Jerry thought of a pattern to show powers of 2. And a power is another way of saying an exponent. So here are a list of 6 numbers in Jerry's sequence. 1, 2, 4, 8, 16, 32. So this one is trickier to write an expression for, because it's clearly not just adding a number each time or multiplying. So we have to think about, again, a power of 2. So think about how we could write this if we're using exponents or powers. Yeah, and so I see a lot of people talking about this or writing it again. And if we think about it, 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4, 2 to the third power, again, 2 to the third power is not 2 times 3, it's 2 times 2 times 2. So that would give us 8, 2 to the fourth power is 16, and so on. So the correct answer, again, would be 2 to the n power. And again, it's starting with 0, so 2 to the 0 is 1. So here's another one to consider, the sequence that follows a +3 pattern. So if it is a plus pattern, how can we write the formula for that using notation? The f of n is a function notation. So again, that just means we're creating an expression using n to represent the terms. That's what that says. A sub n, f of n is just like y. It replaces our y. So f of n, f parentheses n, it's the same way of saying y equals So you'll write f of n equals, and then your expression. That would be how you write the equation for this. And this one's a little trickier because it doesn't start with 3. If it started with 3, it might be a little easier. So we have to think about how we can do this. So go ahead, and again, you're going to write the formula right in there, and then we're going to talk about the formula. So yeah, so you should get something like what's in B actually. So again, it's going times 3. So 3n would be what we got if it started with 3, but it starts with 4. So if we look down at B, it says, does the formula f of n, again, f with the parentheses n, we just pronounce that as function notation, f of n equals 3 times the quantity n minus 1 plus 4. Does it generate that same sequence? Why might you prefer this formula to what you generated for A? So if we, again, n is the number of the term that we're plugging in. So if we plug in 1, we have to get 4 out. So if we plug 1 in, 1 minus 1 is 0. 3 times 0 is 0 plus 4 give us 4. If we plug 2 in, 2 minus 1 is 1, times 3 is 3, and 3 plus 4 is 7. So it works there as well. So it is working. Why might people prefer that formula? All right, so here's what we're going to do. So we just figured out that formula. We have, again, this is the same as what is listed up above. If we plug, again, it would go 4, 7, 10, just like above, 4, 7, 10, 13, 16. So your job is to plot these points on the graph. So you're going to take the red circle and plot it. So at 0, it's at 1. So you'll drag that right on the y-axis at 1. At 1, it's at 4. So go ahead and post it at 4. At 2, it's at 7. 3, it's at 10. So go ahead and post those 4 red dots on your graph. And then you're going to drag the yellow circle to whichever side. If it's true, you'll drag it to the left. If it's false, you'll drag it to the right. The sequence created is a linear graph. So if we go back, again, linear, we said, means that it has to be a straight line. If it's curved in any way, or if it's circular or anything like that, it would not be linear. So your job is to tell me, if we connected all these dots with a line, would it create a straight line? If it would create a straight line, again, that would make it linear. You're going to drag your yellow circle to the true spot. If it isn't, you would drag it to the false spot. If we go over these, again, you might have 3n plus 1 as your equation that you created for the pattern. That would work, again, if we plug in 1. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. So you could have created something like that. Yeah, it did work. I'm not sure. Would anyone rather use this? This almost looks more complicated at 3n plus 1. So I'm not sure if I would use the pattern for B, but you might have. This one says since there's a plus 3 pattern, the nth term is just the first term plus 3. That's why, because they have 4, and then you add 3 for every other term. And then if we look at the graph, yeah, if we check this out, it looks like all of these dots would create a straight line if we connected them. So they would all be on the same line, and it would be a linear graph. All right, here's another one now. So for this time, the numbers are getting smaller. It is a -5 pattern. So think about what we could do to create a pattern for this. And again, if we go back, remember, when it was getting bigger, we had 3n plus 3 times n minus 1 plus 4. If it's getting smaller, it might change something. So think about it. It starts with 30. This one started with 4, and we had 3 times n minus 1 plus 4. If this one starts with 30, it might be plus 30, but we have to think about how it could get smaller each time. And then think about the 20th term in the sequence. Yeah, so we start with something like this could work, 35 minus 5n. Again, we start with that number and then we're subtracting 5 each time. So if we plug 1 in, 35 minus 5 would be 30. If we plug 2 in, 35 minus 10 would be 25, and so on. So if we plug 20 into that equation, we would get a negative number because, again, if it keeps getting smaller, we would go past 0 and into the negatives. You would actually get negative 65. Good job if you got that one. All right, so again, if we graph this one now, the numbers are getting smaller. So go ahead and plot this on your graph. You'll have those 4 red dots. You're going to drag them onto the graph and then connect your graph. You don't have to draw a line connecting them, but just put all 4 of those points on your graph. And once you do that again, did that sequence create a linear graph? It's definitely different than the first one, but if you have all your points plotted and you can connect them, if it makes a straight line again, it's going to be true. If it is not a straight line, it'll be false. So again, plot your points, and then you're going to check it and drag your yellow dot to whichever side you think it goes to. And if we look at it, it is decreasing. Or our slope would be negative. It's going downwards. From left to right, it's going down. So again, we call that decreasing. But yeah, it is still a straight line if we connect those dots. It's okay that it decreases. It'd be okay if it increases. But it would be a straight line, so that would be linear. All right, another similar one. However, this one now says the pattern is times 5. So for doing multiplication, think about how you could put 5 times 5 into an equation to get 1, 5, 25, 125, 625, and so on. And then using whatever formula, if you plug in 10, tell me what you would get. So again, times 5, that'll be a tricky one. And again, if you remember back to that first one, it's not just 5n. Again, if we plug 1 in, that would mean the first term would have to be 5. It's actually 1. If we plug in the second one, it would be 25. If we plug in the third one, 5 times 2 is 10. 5 times 3 is 15. So that wouldn't work. It's not times 5 or 5n is your pattern. So again, that's not your expression. So make sure you check that. And then we have our points here. Go ahead and plot those 5 points on the graph here. And then again, you're going to tell me, does this create a linear graph or something else, or a nonlinear graph? So go ahead and plot those points, and then you can tell me if it's true or false that that is linear. Yeah, and so if we notice it, 5 to the n power. Again, if we plug 0 in, 5 to the 0 is 1, 5 to the first is 5. So we kind of talked about this one. If we plug 10 in, 5 to the 9th is 1,953,125. So it's okay if you used a calculator for that one. Again, that would give you a huge number. So if we look at our graph, it is starting out, it's rising fairly slow, and then it gets steeper and steeper. Again, if we tried to connect these, this is clearly curved, and it starts to rise at a very quick rate. So this would not be a linear graph. So go ahead and you are going to do the rest of these in your groups. I will open the breakout rooms. And again, as always, if you have any questions or concerns, you can flag me down. But again, like normal, try to work with your partners or your groups to work through this. Someone in your group may know the answer, so it's totally fine to ask them. Please don't sit there quietly if someone's asking a question.